Hello, welcome to Chapter 6, Section 4, the final video for this section where we're going to do the application problem. This one actually is a little bit better than the other application problem involving the bird population. If you were watching them in order, you know the one I'm talking about. When I find the volume of a rectangle, if I have a sliding scale on it, which means I have a variable measurement, then I'm going to have length times width times height, which is going to give me something to the third power. So this one actually makes a little bit more sense. Okay, so we'll see how this goes. The volume of a cargo container is modeled by this function. V of x equals x to the third power, subtract 39x, subtract 70. Cool. We want to identify the values of x where this function equals 0. That's from the graph. And then we're going to use the graph to factor. I'm going to factor using synthetic division, but we're going to see how that's related to the graph. It looks like my scale here, my x-axis, is going by 2. So I got 2, 4, 6, 8. It looks like one of my zeros right here is x equals 7. That's actually right here. This 0 looks like x equals -2, and this 0, so I go 2, 4, that looks like x equals -5. So it looks like I have my zeros from my graph, x equals -5, x equals -2, and x equals 7. Let's see if any of those actually work. I'll pick the 7 first. Now my function is missing an x to the second power. So it's 1, 0, -39, -70. Let's use synthetic division. I get 1, 7, 7, 49. 49 plus -39 is 10, and 7 times 10 is positive 70, which gives me no remainder. So far my factors are going to be x subtract 7. No, wait, where'd I get the x subtract 7 from? So over here, if x equals 7, if I subtract 7 from both sides, I get x subtract 7 equals my 0. Right? Remember, if I take my x value and subtract the 0, I get, subtract that number that we call the 0, I get the number 0. That's why that number is called the 0. What did I have left? I have x squared plus 7x plus 10. Can I factor this one any further? By the way, let's name it. This is v of x. Can I factor this any further? Well, I can try using synthetic division with -5 or -2. I think those are my zeros. But let's use our skill that we already know from Algebra 1, which we used in quadratics. This is a quadratic. What two numbers multiply to give 10 that add to give 7? Don't forget the x minus 7, that stays there. This is x plus 2 times x plus 5. And that is my function. So this is my function in standard form. This is the same function in factored form. They are the same. They're just two different forms. This is actually simplified. This is not. But this is more useful. Why? Because if I set it equal to 0, each of these terms could equal 0, so I get x equals 7, x plus 2 equals 0, so I get x equals -2, and x plus 5 equals 0, so I get x equals -5. Which is what I said they would be up here. By the way, if I'd started with either of these, I would have ended up with the same three terms, just in different order. Now, that seems like maybe I don't know. Maybe it just seems kind of weird, but guess what? This This whole thing right here, get rid of the cargo container stuff, this whole thing right here is getting us toward the big idea in chapter 6. And by the way, before I forget, I meant to do this. Hopefully I got space. I have a rectangular prism as my it's a box, as my cargo container. What are the dimensions of this? Well, the length and the width and the height, whatever it's oriented, it's x minus 7 times x plus 2 times x plus 5. So, for example, if x equaled 10, it would be 3 by 12 by 15. So that's one way of doing it. Okay, good luck with that. Ask questions. We'll see you.